Okay, we are looking at question 4 from part 1 of exam 2, and this question tasks us with finding the configuration of each labeled carbon. R and S configurations can be determined by ranking the atoms or groups attached to each tetrahedral carbon by importance or atomic size, and then rotating the molecule so that the least important group is behind, and then assessing whether the levels of importance go counter or normally clockwise to create an R or S configuration. So to start with carbon 1, we can see that there is an undrawn implied hydrogen attached to this carbon, and it would be coming forward because this CO2 group is going backwards, so it can be drawn like this. And so the CO2 group can be labeled first as the most important because of the two highly electronegative and large oxygen molecules that it is attached to. And likewise, this hydrogen is going to be labeled as the least important because it's the smallest. And that leaves us with two carbons on either side of this central carbon. And both carbons obviously have the same atomic size. However, this carbon on the right is attached to many more carbons and groups, meaning it would be more important than the carbon on the left. So we're going to label that carbon 2, and then this carbon on the left is carbon 3. So now we have to place the hydrogen in the back because it is the least important molecule on this tetrahedral configuration. So to do that, we're going to redraw this structure. And if you imagine flipping this 180 degrees, that the hydrogen is now facing the back and the CO2 group is on top up here. That's number 1. Then the second and third carbons would switch places, so 2 and 3 would be placed like that. And looking at this way, we have a counterclockwise configuration, meaning it is S, so we can label carbon 1 as S configured. And moving on to carbon 2, we see that there is already a hydrogen drawn on, so this tetrahedral carbon shows all 4 bonds. So the hydrogen we can automatically assume, because the other 3 molecules are carbons, the hydrogen is going to be the least important atom attached to this central carbon, so we'll go ahead and label that as number 4. And to rank the other groups in order of importance, we want to look at what these groups are directly attached to. So this carbon below is attached to a sulfur molecule, which is considered pretty large. Then this other carbon to the right is attached to a nitrogen, which is also pretty large, as well as all of these other groups over here. And this carbon is attached to another carbon on both sides, and then the oxygen methyl group. So ranking these in order, we're going to rank the bottom carbon as the most important down here because it's attached to the largest molecule, which is the sulfur. And then this carbon over here, we're going to rank as number 2, leaving this one to be ranked as number 3. Luckily, the hydrogen is already in the back on this molecule, so we can just redraw this structure more simply down here. It'll look like this. And once again, it is counterclockwise in order of most to least important, so it's an S configuration again. So to now look at this third carbon, we once again have all 4 atoms attached to the tetrahedral carbon in the center, including a hydrogen, so we can mark the hydrogen as least important again. And now we have a nitrogen attached, a carbon down here, and then this carbon over here. Because the nitrogen is larger than either of the carbons, that's going to be marked as the most important group. And that leaves the 2 carbons, one to the left and one to the right, The carbon to the right is more important because it's attached to multiple phenyl groups, unlike the carbon to the left, which is attached to just an empty ring. And so we're going to rank this carbon as 2 and this carbon over here as 3. So like the second molecule, the hydrogen is already in the back, so we'll just redraw the structure down here without rotating it or anything, and we'll see that it moves clockwise, meaning that it is an R configuration. And now the problem is complete.